Hello students, welcome back. Let's solve the next set of questions of electricity chapter from ncert class 10 science book. The first question is, judge the equivalent resistance when the following are connected in parallel. First one is 1 ohm and 10 to the power 6 ohm, and second one 1 ohm, 10 to the power 3 ohm and 10 to the power 6 ohm. Second question, an electric lamp of 100 ohm, a toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much current as all the three appliances, and what is the current through it? The third question is, what are the advantages of connecting electrical appliances in parallel with the battery instead of connecting them in series? The fourth question is, how can three resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of bit A 4 ohm, bit B 1 ohm? And the fifth question is, what is bit A the highest and bit B the lowest resistance that can be secured by a combination of 4 coils of resistance 4 ohm, 8 ohm, 12 ohm and 24 ohms? So let's solve the first question first. So in the first bit we have two resistors of 1 ohm and 10 to the power 6 ohm connected in parallel. So let's draw the circuit diagram first. So here we have two resistors. So this is 1 ohm and this is 10 to the power 6 ohm. They are connected in parallel. We have to find out the equivalent resistance. So let's write down the formula first. So for a parallel combination, the equivalent resistance is given by 1 by Rp is 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Here R1 is 1 ohm and R2 is 10 to the power 6 ohm. So we'll substitute the values in this equation. So 1 by Rp is 1 by 1 ohm plus 1 by 10 to the power 6 ohm. The LCM is 10 to the power 6. So it is 10 to the power 6 plus 1, 2, 3, 4, 5, 6 plus 1 by 10 to the power 6, which is 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. So this implies Rp will be 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, which is approximately 1 ohm. So this implies the resistance of this parallel combination is approximately 1 ohm. So this is the first answer. In the second bit, the resistance R1 is 1 ohm, the resistance R2 is 10 to the power 3 ohm and R3 is 10 to the power 6 ohm. These are the three resistors and they are connected in parallel. So this is 1 ohm, this is 10 to the power 3 ohm and this is 10 to the power 6 ohm. So now again the equivalent resistance formula is 1 by Rp is 1 by 1 ohm plus 1 by 10 to the power 3 ohm plus 1 by 10 to the power 6 ohm. So the LCM is 10 to the power 6. So it is 10 to the power 6 plus 10 to the power 3 plus 1. So this implies Rp will be 10 to the power 6 by 10 to the power 6 plus 10 to the power 3 plus 1. So this will be Rp will be 1, 2, 3, 4, 5, 6 by 1, 0, 0, 1, 0, 0, 1, which is approximately 0.999 ohm. Hence, the equivalent resistance in parallel for the second bit is 0.999 ohm. So this is the answer to the second bit. This was the first question. Let's now solve the second one. So in the second question, there is a circuit in which there are three electrical devices, namely electric lamp whose resistance is 100 watt, a toaster of resistance 50 ohm and a water filter of resistance 500 ohm. They all are connected in parallel and are connected to 220 volt source. So there is another iron which is connected to the same source. That means the source is having a supply voltage of 220 volt and it's saying that it takes as much current as all the three appliances. That means the current flowing in this circuit is equal to the current that is flowing in the second circuit in which the iron is connected. So what is the value of current flowing here? The current value in the second circuit in which the iron is connected is also the same, and the iron is also connected to the same potential, that is 220 volt. We have to find out what is the resistance of this iron. So from this question, we understand that the current flowing in the first circuit is equal to the current flowing in the second circuit. The second point is the resistance of the iron is equal to the equivalent resistance of the three appliances. So first let's find out the current flowing in the first circuit. So we'll find out the current flowing in the first circuit using Ohm's law. But before that, let's find out what is the equivalent resistance of these three devices connected in parallel. So the equivalent resistance is given by 1 by Rp is 1 by 100 plus 1 by 50 plus 1 by 500. The LCM is 500. It's 5 plus 10 plus 1, which is 16 by 500. So Rp is 500 by 16, which is 250 by 8, which is 125 by 4, whose value is 31.25 ohm. So the equivalent resistance in parallel is given by 31.25 ohm. Since the equivalent resistance of these three devices is equal to the resistance of the iron, the resistance of iron is also 31.25 ohm. So this is the resistance of the iron. Now let's find out the current. From Ohm's law, V is equal to IR. So this implies I will be V by R. So I is voltage is 220 volt by R is, we'll write down this value, 125 by 4, which is 220 into 4 by 125, whose value is 176 by 25, that is 7.04 ampere. Hence, the current flowing in the circuit is 7.04 ampere. So this is the current in the first circuit as well as the current flowing in the second circuit in which the iron is connected. These are the answers to this question. Now let's go over to the next question. So now let's look at the advantages of parallel circuit. First is there is no voltage division. All the devices work at the same voltage. Hence they can draw current as per their resistance. That is, the potential difference at V is equal to the potential difference between X and Y. So the device R1 is working at a voltage V, and the supply voltage to the resistance or the device R2 is also V. So as per their resistance, they can draw different values of current. So current in both the devices will be different based on the value of their resistance. Second one is connecting the devices in parallel reduces the overall resistance in the circuit. If we connect the devices in parallel, it will reduce the overall resistance in the circuit. Third, if one device is damaged, it will not affect the working of the others. That is, if let's say this R2 is damaged, there is some fault in this device, so there will be no current in this circuit, but the current will pass through the device R1 or the resistance R1 without any hindrance, and the device will continue to work. Similarly, if R1 gets damaged, then the current will pass easily through R2, and hence each device work independently of the others in a parallel circuit. The fourth one is separate off-on switch can be applied across each device. Here you can put a separate switch and operate R1, and here you can put a separate switch and operate R2. So separate off-on switch can be applied across each device. So I hope you have understood this. Let's now go over to the fourth question. In the next question, there are three resistors. R1 is 2 ohm, R2 is 3 ohm, and R3 is 6 ohm, and they are to be connected in such a way that the effective resistance upon connecting them will be first 4 ohm and the second one will get a resistance of 1 ohm. So there are various ways of connecting these three resistors. We can connect all three of them in series, all three of them in parallel, or the first two in series with the third in parallel, or first two in parallel with the third in series, or 2 ohm and 6 ohm in parallel with 3 ohm in series, or 2 ohm and 6 ohm in series with 3 ohm in parallel. So like this, there are numerous ways in which we can connect these. So let's see by connecting 3 ohm and 6 ohm in parallel with the third one, that is 2 ohm in series. So let's write down 1 by Rp, the equivalent resistance in parallel is given by 1 by 3 plus 1 by 6. So this gives an LCM of 6. So it is 2 plus 1, which is 3 by 6, that is 1 by 2. So the Rp is 2 ohm. Now we'll have to connect the equivalent resistance of 3 ohm and 6 ohm with 2 in series. So Rs is given by 2 ohm plus this equivalent resistance 2 ohm, which is 4 ohm. So in order to get a resistance of 4 ohm, you have to connect 3 ohm and 6 ohm in parallel with 2 ohm in series, and the circuit diagram would look like this. So this is 2 ohm, 3 ohm and 6 ohm. So if we connect in this way, the equivalent resistance will be 4 ohm. This is the first bit. In the second bit, it is asked to connect these three resistors in such a way that they will produce an equivalent resistance of 1 ohm. So let's try now by connecting all of them in parallel. So in parallel, we know the equivalent resistance is given by 1 by 2 plus 1 by 3 plus 1 by 6. The LCM is 6. It is 3 plus 2 plus 1, which is 6 by 6, that is 1 by 1. Hence Rp is 1 ohm. Hence if we have to get an equivalent resistance of 1 ohm, we have to connect all these three in parallel, and the circuit diagram would look like this. All three when connected in parallel gives an equivalent resistance of 1 ohm. So this is 2 ohm, this is 3 ohm and this is 6 ohm, and R equivalent in this case is 1 ohm. So this is the answer to the fourth question. I hope you've understood it. Let's now go over to the fifth question. In the fifth question, we have four resistances of value 4 ohm, 8 ohm, 12 ohm and 24 ohm. We have to connect them in such a way that the equivalent resistance produced by them will be maximum and the minimum. Now remember children that the highest value of resistance will be achieved by connecting all of them in series. So if we connect all the resistors in series, we'll get the highest resistance because all the values just adds up. So the value which comes out to be will be the highest. To get the lowest resistance, we have to connect all of them in parallel. So parallel combination reduces the overall resistance of the circuit and produces the lowest resistance. So the highest resistance, if we have to get highest resistance, let's find out. So it will be Rs is given by 4 ohm plus 8 ohm plus 12 ohm and 24 ohm, which gives a total of 48 ohm. Hence the highest value of resistance that can be achieved by combining all these four resistors is 48 ohm, and for that we have to connect all of them in series. For finding out the lowest value of resistance, we'll have to connect all of them in parallel. So 1 by Rp is 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24, which gives LCM is 24. It is 6 plus 3 plus 2 plus 1, which is 12 by 24, that is 1 by 2. Hence Rp is 2 ohm. So the minimum value of resistance which we will get by combining all these resistors is 2 ohm, and for that we have to connect all of them in parallel. So this is the answer to the fifth question. So these are the solutions to these questions. I hope you have understood them. If you found this video helpful, please like it, share it with your friends, and subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.